Hi guys, so we're gonna do a little graphing today, so definitely have some graph paper and a calculator ready to go. We're gonna be graphing polynomial functions given some of the information that we learned about in the last lesson and by making a table of values. So let's start off with defining, we've got our objectives, graph the function, but we also need to know what is a relative maxima and relative minima of a polynomial function. So I just kind of make a little sketch here. So here's a function. And this point here, we'll call it point A, and this point down here, we'll call that point B. One of them, so that would be point A is a relative maxima. I'm just going to abbreviate here. And point B is what we call a relative minima. All right? And so these are points on a graph. I'll just define them together here. They are points on a graph. Oops. Where no other nearby points have a greater, happen there, have a greater, which would be the relative max, y coordinate, or a lesser, which would be the relative minima. Y coordinate. Okay, so these are often called turning points on a graph. So A and B, as you notice, those are where the graph turns and goes a different direction. So on this graph, it's going up and then back down and then back up. So those are called the turning points of a graph. And the interesting things about turning points is that if this is a cubic function, which it is, so we have two turning points for a cubic function. So the degree and the turning points have a relationship that, I'll write it in green here. So the graph of a function of degree n has at most n minus 1 turning points. So in my example up here, it's a degree of 3 because it's cubic and it has 2 turning points. Okay, so let's begin graphing. So the function we're going to graph, f of x equals negative x to the third minus 4x squared plus 5. And we're going to graph that by making a table of values. And we already do know a few things about this graph. Okay, we know it's a cubic, so we know the ends are going in opposite directions. And so we're going to use that information to help us graph. The leading coefficient is negative, all right? So I'm going to write this out. So since It's an odd function with a negative leading coefficient. We know that that f of x, the function itself, is going to approach positive infinity as x approaches negative infinity. They're going to go in opposite direction. It's going to go opposite of what it would normally do. And on the other end, f of x is going to head towards negative infinity as x approaches positive infinity. Okay? So remember, this is the negative infinity side for x. This is the positive infinity side for x. And so on the left side, the function is going to go up, and on the right side, the function is going to go down. Also, a really important part of this function is the constant. So that's your y-intercept. So c equals the y-intercept. And that's usually how I start my table of values, is by putting a point of 0, 5. So wherever x is, f of x is going to be 5. Or excuse me, when x is 0, f of x is 5. That's your y-intercept. And now from here, we are going to substitute values in for x and graph the function. And really, the amount of points you put in for x, or values you put in for x, is just kind of dependent on making enough points to see the graph, okay? So really important, though, that you use parentheses when using substitution, because that negative sign right there is outside the x as well as the cube. And so really important that you go ahead and use a calculator, but use parentheses on your calculator. So if I substitute in the value of 1 for x, the negative is outside the parentheses, so I put negative, parentheses 1, parentheses cube, minus 4, parentheses 1, parentheses square, plus 5. And that should give you the value of 0, all right? So now I want to, if you notice, that is an x-intercept, which is pretty cool. And now I just want one more value just to make sure, because it looks like it's headed downward as f of x is going to decrease as x increases. Let's make sure. So if I put in 2, I get negative 19. And now I notice that f of x is headed to negative infinity. For x, okay? So I'm going to go ahead and stop there. F of x is approaching negative infinity as x approaches positive infinity. So on the other side of 0, let's put in negative 1. And again, really important you use parentheses here because the negative is not part of the x. So negative and then parentheses negative 1 cubed minus 4 parentheses negative 1 squared plus 5. And that gives me a value of 2. So keep going. I want a few more values. I'm going to put negative 2 in. I'm going to get negative 3. Negative 3 gives me negative 4. So I'm continuing to go down, but here's the problem. F of x needs to go up when x goes down. So if I put negative 4 in, I get 5, and now we're headed back up. So I'm going to stop there because if I put in negative 5, it's going to get really big. So now we're headed to positive infinity. So I'm going to stop, okay? So that's what I needed to see. So now I plot these points, and I have negative 4, 5, negative 4, 5. 1, 2, 3, 4. That's there. And I have negative 3, negative 4. Okay. And I have negative 2, negative 3. Negative 1, 2. 0, 5. 1, 0. And then 2, I can't graph that. So I have enough points, and so I'll go ahead and graph. This end is going upward, so I'm going to go down, turn, hit the y-intercept, and then go back down. So we notice we have on the function as that f of x is headed towards positive infinity on the left side here as x goes towards negative infinity. On the right side, f of x is headed downward towards negative infinity as x goes towards positive infinity. We have our y-intercept. We have two turning points, and so those are the relative maxima and relative minima, and they want you to estimate those x coordinates. So here is a relative minima at x equals 1, 2, 3, or negative 3, excuse me. So that's a relative minima at x equals negative 3. And here we have, oops, that should be at 0. We have a relative maxima at x equals 0. And so those are your two turning points. And we actually have 3 real roots, if you didn't notice that, which is pretty cool to see. We have 1 exact root, and then we have 2 that are estimated roots. So we have 3 real roots. I'm just adding that in there for you. Okay, so let's do another one. All right, so since this is an even degree and the ends are going in the same direction, because the leading coefficient is positive, so we know that f of x is going to approach positive infinity as x approaches negative infinity. And we also know f of x is going to go the same direction, positive infinity, as x approaches positive infinity. We've got our y-intercept, okay? And it's a 4th degree polynomial function. All right, so our y-intercept is 1. So again, like I said, I'm going to put 0, 1 in there for my first point, and then I'm going to put a few points on either side of 0, positive and negative for x. So I put in 1. Make sure, again, you use parentheses around x when using substitution. So if I put in 1, just to save ourselves time, I get negative 3. So we're headed downward, and the function needs to go up, right? So if I put in 2, it's still heading down, negative 7, going down. We need it to go up. So I'm going to put 3 in. Oh, I get 19. We can stop because we're going upward, okay? On the other side, I put in negative 1. I get negative 1. That's going down. It's got to go up. I put in negative 2. I get 9. That's going to go up. So we can stop right there because it's headed up. So the function needs to go up. It needs to head towards positive infinity on both ends of x. So I can stop there and plot a few points. Negative 2, 9 is up here. And negative 1 is here. 0, 1, 1, negative 3. 2, negative 7, and then it's going to go turn back around, which I don't have enough space for. So it's going up on this end, and it's going to go down, turn, hit there, and then go down, and then come back up, okay? So we do have both ends going up like it should, and we notice we have a turning point here, here, and here. So we can have multiple maximum points and minimum points, so that's okay. So we have, I'll just list them over here. So we have 1 relative max at x equals 0, and we have 2 relative minimums at x equals negative 1 and x equals 2. And then look, we have 4 real zeros. 1, 2, 3, 4. Yeah, 4 real zeros. Okay. So hopefully you're getting the hang of this, all right, because you're going to do the next one on your own. Here you go. So go ahead and pause and do this one on your own. Okay, so real quick, because it's an odd degree function and the leading coefficient is positive, we know that f of x is going to head towards negative infinity as x goes towards negative infinity. They go in the same direction. And then on the other side, f of x is going to head towards positive infinity with x, so as x approaches positive infinity. So the function goes in opposite directions, but it goes the same direction as x. So we've got our y-intercept is 5 here. So we have 0, 5 is our y-intercept, okay? If I put in 1 for x, I get 3. So as x is increasing, f of x is increasing, but let's make sure. So if I put in 2, it has, 1. Uh-oh, it turned back down. So let's put in a 3. I get 5. And if I put in 4, it's going to go way up. So this side's shooting up, which is good. Okay. If I put in -1, I get 1. So that's not going in the same direction yet. If I put in -2, I get -15. So now we're going down. So we're good now. Okay. So now let's plot these points. So 0, 5. I always like to put in the line or something first. -1, 1. -2. -15, which is way down there. So I can't really put that on my graph, but I have 1, 3, 2, 1, and then 3, 5. So it's headed that direction. So it's going like this. Okay, there we go. Okay, so we have 2 turning points here and here, and we have 1 real 0 this time. So we have 1 relative max at x equals 0, and we have 1 relative min at x equals 2, and we have 1 real 0. And that means if we have 1 real 0, that means we have 2 complex zeros because they come in pairs. All right, guys. So be prepared to do just a little bit of graphing in your homework today. And it really does help to first look at the function, the leading coefficient, like the degree of the function, is it odd or even, and is the leading coefficient positive or negative, and then, of course, the y-intercept. Those are key points or key parts of the function to first notice before you start your graph.